Morning, guys. Happy Monday. Right, we'll start with the homework. Okay. So PQ or S is a parallelogram. Find the measure of the following segments and give a reason for each answer, or give a reason in each case. Okay, so QP. Okay, so QP is along the top there. And I might just do it out to the side. So QP is equal to 20. And how do we know? I'll move that now. Okay, we know because opposite sides of a parallelogram are equal. Okay, part B, PS. PS is there. Same thing here, PS is equal to 16 for the exact same reason. Opposite sides of a parallelogram are equal. Part C, MQ. So there's MQ. MQ is equal to 15, and that's because the diagonals bisect each other. Can't move that yet. Okay. So this, trying to work the picture here now, this diagonal here from P to R cuts the other diagonal in half, which means if this bit of it is 15, the other bit has to be 15 too. Okay, and the last one, SQ. Oh. So SQ is this whole line. So if MQ is 15 and SM is 15, then SQ has to be 30. And the reason is the same, as in the reason is because I knew MQ was 15, so the reason is the same. Last one's a bit weird. Okay, we just had to do the first one. Find the measure of the angles A, B, and C in each of the following. Show as much work as possible. Okay. So, okay, first one I'm seeing is this one here, this angle here, and this angle here are the same because they're opposite angles in a parallelogram. So B is 58 because they're opposite angles in a parallelogram. I see another one. So parallel line, transversal, parallel line means this one equals that one. Yeah, so that's a Z shape. So I know that A equals 23, and the reason I know is because I found a Z, and that is alternate angles. Yeah? And, oh yeah. So that there is a triangle. So A, which is 23, plus 58, plus C has to equal 180 degrees because they're the three angles in a triangle. So that means C is going to be 180 minus 23 minus 58. So C is 99. And there may well have been other ways to do that. I'm sure there was. Anyway, so they're the three in question 7. I'm just going to add a new page here. Just for today's homework. Right, and then we will continue. So, parallel lines and triangles. So, theorem number 9. So this is our 9th theorem to come across. And it says, if 3 parallel lines cut equal segments on some transversal line, then it will cut equal segments on any other transversal. Okay, so sounds complicated. It's actually not at all. So what we have here, okay, we have one line, two lines, and 3 lines. Yeah? There are 3 parallel lines. We know they're parallel because they've got those little arrows on them. Now, I don't know which one's the original line, but it doesn't really matter. So let's say this is the information we were given. So we were given the 3 yellow parallel lines and we were given the green transversal. Okay? If you look at the green transversal, can you see that the yellow lines cut the green transversal into 3 and 3? So it cuts the green transversal into equal segments. Yeah? So essentially what that's telling us is that the 3 parallel lines are the same distance apart. So if you draw a line cutting through them, it's going to split equal parts. So, sorry, hang on. Okay, so this bit here is the same as that bit there. Does that come through yet? No. Oh, there, it's coming through now. Okay, so the lower bit is the same as the higher bit, okay? So essentially what the theorem says is that if I draw any other line, it will cut that line into equal segments in between the... So if I'm just going to draw a random line, okay? So let's go red, and here's a random transversal. There's one there. Yeah? Now, I know... blue. I know that whatever length that bit of the line is, that bit there, this bit is the same length. Okay, so if that top bit's 5, then the lower bit's 5. If that top bit's 6.2, then the lower bit's 6.2, because these parallel lines cut equal segments off my transversal, off any transversal. Okay, so if three parallel lines cut equal segments off one transversal, that means those parallel lines are an equal distance apart, which means no matter what transversal you draw, it will cut equal segments off every single transversal. Okay, so this one here then, I don't know if this is still sinking. So find the length of AB, all right? So we have 1, why is it always your class that this malfunctions? It really doesn't happen with anyone else. So there's 1, 2, 3 parallel lines. Okay? And then here, there, I have a transversal. And the question tells me that this bit down here, the bit at the bottom, from F to E, is 7 units in length. And it tells me that the bit from E to D is also 7 units in length. So what we have is 3 parallel lines that are cutting a transversal into equal segments. So we know from the theorem that if it cuts one transversal into equal segments, it's going to cut any transversal into equal segments. So if I look then at this transversal over here, I've been told that the lower part of it is 5 units in length, so that means the upper part must be 5 units in length. So AB is 5. That's it. So here's another one, just with a bit of algebra in it. So find the value of A if x, z plus p or is 24. Okay, so we have 3 parallel lines. 1, 2, 3 parallel lines. We have a transversal over here. See it there? And it says that that's been cut into 2A and 2A, which means it's been cut into equal segments. So if that one has been cut into equal segments, then this one must also be cut into equal segments. So if the top part is A, then the bottom part is also A. Okay? And it says that this thing here says that xz, which is A plus A, plus PR, which is 2A plus 2A, equals 24. Okay, so those A's have invisible ones. So we have 1, 2, 3, 4, 5, 6 A's there. So 6A is 24. I want to isolate the A. So I need to divide by 6 to cancel. Divide by 6 for balance. So that means A must be 4. And we do have units centimeters. Okay? So the theorem is very straightforward. Very, very straightforward. It's literally just, if it's equal segments off one, it's equal segments off all. So this theorem, I may as well keep going because I think that first theorem is quite straightforward. Okay, so theorem 10, our 10th theorem. Okay, so it says let ABC be a triangle. If a line L is parallel to BC, okay, so I'm just going to draw this as I read it, all right? So just make sure you can see that. Okay, so we have ABC. right? So there's ABC. Oh, sorry. Okay, so A, B, and C. Right, so let ABC be a triangle. Done. If the line L is parallel to BC, right? So I'm going to draw a line in here. And it's going to be parallel to BC. Then it cuts AB in the ratio S's to T. Okay, so AB is over on the left, and it cuts it up into the bit on top is S and the bit on the bottom is T. Okay, so like S could be, I don't know, 6 and T could be 1. So it cuts it in the ratio 6's to 1. Yeah? Then, now this is based on the previous theorem. If that's the ratio that it cuts the left-hand side of the triangle, then it's going to cut the right-hand side in the exact same ratio. That's the theorem. Okay, so if you draw in this parallel line here, parallel to the base of the triangle, then whatever ratio it cuts the left-hand side of the triangle into, it will cut the right-hand side into the same ratio. Yeah? So from there, essentially, you can kind of make so whatever the top bit is, right? So top on left divided by bottom on left. Okay, so whatever you get when you divide, because they're in the same ratio, whatever you get when you divide the top bit on the left over here by the bottom bit on the left, it should give you the same answer as when you divide the top on the right over the bottom on the right. Okay? Because the ratio is the same. Now, there's loads of variations of that, so I'm just going to try a question and see. Sometimes it's easier if you just do a question. Okay, so let's look here. So I have P or T, and that's a triangle, and it is intersected by the line QS. And if you look at the line QS, can you see that QS is parallel with the base? Yeah, so that means that line is going to cut both sides of the triangle in the same ratio, because that's what the theorem says. Okay, so we don't know what QP is, but whatever QP is divided by 2 is equal to 6 divided by 3. Okay, can you see what I did there? I did the top on the left divided by the bottom on the left, and that has to be the same as the top on the right divided by the bottom on the right. Okay, because they're in the same ratio. Now, like, there's a couple of ways of doing this. You might just look. So if you want to go from 3 to 6, that's double. So the top part of the triangle is double the bottom. So you can apply that and figure out QP. I think a more consistent way of doing it, and the way I'd like to do it, is using cross multiplication. So you multiply the 2 by the 6 and you multiply the 3, by QP. Okay, so you get 3 QP equals 12, and then you divide by 3 to cancel the 3 and divide by 3 for balance, and you get that QP equals 4. And if I put the 4 in, you can see that on the left-hand side, the top part is twice as big as the bottom part. And on the right-hand side, the top part is twice as big as the bottom part. And that means they're in the same ratio. Okay, they're both in the ratio 2:1. Right, that's kind of it. Right, look, we'll give the questions a go, and if there's any outstanding problems, then I'll deal with it when I'm correcting the homework on Wednesday. So do let me know, please, if there's any issues. Okay, so this is based on the first theorem. Okay, that's nicer. Let's do question 2, and we'll do the last part there. Okay, so question 1A, question 2C, and then we'll do those two there. Question 6, and we're going to do C and D. Okay, so we have two questions using the first theorem. Two questions using the first theorem, and then two questions using the second theorem. The second theorem is kind of like, it's not difficult, but it's tricky enough to explain. So it's one of those ones where you're better off just giving the questions a go, and then if there are any concerns, we can go through them, and it's easier to explain nearly when you've done the questions. So give them a good go. And do let me know if you come across any issues, because I don't want to leave anything that you don't understand. Okay, so there you go. Two questions using the first theorem, which was the one where if three parallel lines cut equal segments off one transversal, then they will cut equal segments off any transversal. And then the second one is if you're not doing that one. Sorry, I have that one in there, but you're not actually doing it. So the second theorem then was, if a line is drawn parallel to the base of a triangle, then it will cut the left-hand side of the triangle in the same ratio as it cuts the right-hand side of the triangle. Okay, and then you have to use that to find unknown lengths. All right. Okay, so give it a go. Let me know. Please do let me know if there are any issues.